Hello, my friends, and welcome back to another exciting module here in Biology 102. In fact, this is our last module for the course. And before I begin our weekly welcome, I want to say something to you from the bottom of my heart. Over the last 14 weeks, you have done outstanding things in being able to can take broad concepts, themes found in the natural sciences, a focus on our natural world using biology, and be able to contextualize it into models that we can study, describe, and explain the variety of different phenomena found on our planet. You were able to take very complex data sets, interpret them, and analyze them to gather evidence to support really any claim that um, we make in this discipline, um, and effectively conduct the scientific method and meet the learning outcomes described in the course syllabus, and ultimately become true citizen scientists. Be able to take that knowledge and share it and be able to think constructively about the problem at hand. And I just want to say, I'm proud of you. I'm proud of each and every one of you who have made it this far, and truly hope that you appreciate the information provided and can take that information, continue to learn from it, and hopefully inspire um, a series of changes out here in the Appalachian region as far as scientific literacy and awareness is concerned. But again, at the end of the day, I'm very much proud of you and the great strides that you made to progressively change your body of knowledge. You may not have been someone with a strong science background, but as time has gone on, you mastered the content and the material being covered. And so for that, cheers. But now we need to finish up our semester of study here. And we are going to continue our third thematic section, dealing with the great transitions of the natural world, the stories of great innovation. And so I want you to picture this. Imagine stepping into a time machine and travel at least back to 66 million years ago, shortly after the Cretaceous end of extinction event, a cataclysmic event that wiped out all of the dinosaurs and left basically behind the birds and some random reptile groups. But the world, it looks vastly different. The Earth is still in a rebound phase. It's reeling from the impact of a asteroid that landed off the coast of Mexico, probably about the size of Mount Everest or Texas. And the shock caused a mass extinction. But something exciting during this time is occurring, and that is the rise of new life. To be able to take that center stage and tell a new chapter in Earth's history. And this moment, it marks the beginning of what geologists and biologists define as the Cenozoic era, also known as the age of mammals. Why? Well, again, it's because the dinosaurs have vanished. Mammals are suddenly taking up this new opportunity to fill the ecological niches that were left behind by the dinosaurs. It's a pivotal point in Earth's history, one that sets the stage for the evolution of the mammal biodiversity that we see all around us, and that we are part of that story, being humans. So let's recap some of the phenomena that you will encounter in this week's module. At the beginning of the Cenozoic, the Earth was considered to still be warm and tropical. Think rainforests, palm trees near the that are near the poles, uh, a planet buzzing with new plant and animal life shortly after that extinction. This period allowed mammals to explode in diversity, taking over those ecological niches left behind. But there's one small organism that I think tells us a really great story. And that is a small rodent-like creature that is finding itself in a world with no competition. That rodent could now really explore new habitats, change its biogeographic context and its role in its local ecology, and evolve new features that eventually give rise to future species that we see all around us today, like whales, elephants, but also primates. As we progressively reach our time period, things didn't stay warm forever. Starting with the Eocene epoch about 56 million years ago, the Earth starts to begin to cool down. By the Oligocene and Miocene epochs, that cooling trend accelerated, picking up and eventually leading to the famous ice ages of the Pleistocene, starting around 2.6 million years ago. This cooling event triggered huge evolutionary changes. For example, the formation of ice sheets in Antarctica and the glaciers in the northern hemisphere forced animals to adapt to this changing context. Species that couldn't handle the cold eventually went extinct, while others have evolved traits like thick fur, the ability to hibernate, or even shifted their migration patterns to enter areas or biomes that are much warmer southwards. During these ice ages, we saw the rise of the giant mammals, what we like to define as paleontologists and biologists, the megafauna. And these megafauna dominated the landscape of the Cenozoic. For an example, we see giant carnivores like the saber-toothed cats, powerful predators with massive canine teeth, perfect for hunting prey in colder, open environments. But we also see giant ground sloths, like that inhabited areas of Appalachia, like which would eventually become modern day West Virginia. In the American Great Plains, you saw roaming herds of giant ungulates like mastodons, but also early bison. At the same time, though, more temperate regions supported smaller and more agile animals like rodents, other hoofed grazers, and even canines, many of which resemble animals that we see today. But one of the most exciting parts of the Cenozoic occurred, and this group got their spark in Africa. Do you want to guess which group that is? Well, that is the primates, or at least a little evolutionary offshoot of the tree of primates. That's right, us as humans. You see, when we think about it, it wasn't a sudden leap, but a gradual transformation over millions of years as the climate started to shift. The forests gave way to grasslands, and this allowed for the opening of new environments that allowed primates to take on a variety of adaptations. And three of the best ones that I can think of that help connect us to our primate ancestors is that of bipedalism, the ability to walk upright, larger brains for problem solving and complex behaviors, and the ability to craft tools for survival in this new world. You see, our early ancestors, like Australopithecus, walked on two legs to better navigate the open grasslands and freed their hands so they can use tools as we dispersed out of Africa to take over the world. Now, ultimately, you're probably asking the fundamental question here for this week's module is, why does this even matter? Well, here's how I think about it, coming from the perspective of a paleontologist and someone who studies biogeography, is that studying the Cenozoic, it helps us understand how climate and the environment truly shape biodiversity. You see, it's not just about the fossils that we discover. It's more about the relationship being cause and effect. Think of it like this. Changing climates means that the habitat will change. Organisms that live in the habitats are experiencing environmental pressures that allow for changes in their adaptations. These adaptations will determine if an organism thrives or just survives. This allows for new species and behaviors to show up and allow for innovation to occur. In short, the Cenozoic really teaches us how mammals adapted to a constantly shifting Earth, something we don't normally see in our other modules that we have covered in this thematic section. And that the rapidly changing Earth allowed for organisms such as us to take that center stage and then transform the planet. And so when we learn about the Cenozoic, you're, again, not memorizing the dates and times, but exploring that dynamic relationship between Earth and life, which is the main focus of this course. Every shift in temperature, every tectonic plate as it migrates around the planet, rise and fall of sea levels, changes in the chemistry of the atmosphere, difference in vegetations, these all help write the story of life and biodiversity on our planet and our own human journey. Now, before I depart and allow you to continue to work on your studies for the week, I also want you to be aware that we do have our two final exams coming up. We have one for lecture and we have one for lab. The one for lab tends to be focused more about application of the different concepts, whereas the one for lecture is more about your scientific communication skills. And how we're going to be doing that is that we are going to conduct what we call a bio blitz. And this is something I've been working on for all the other science classes. And so it's a large collaborative exercise because I'm not a big fan of multiple choice examinations. I prefer something that is a little bit more interactive. And what is a bio blitz, though? Well, according to iNaturalist, which is the app that we're going to be using to conduct this, a BioBlitz is an intensive short-term survey of biodiversity within a specific area. In this case, it's going to be the Appalachian region. And this is where scientists, naturalists, and the community members work together to record as many plant and animal species as possible. These events are often used to engage the public in citizen science and contribute valuable data to help aid conservation or even further develop science classes for the future. That's right. The data you collect will help improve the science courses here at Eastern for many years to come, and also raise awareness about local ecosystems. And so you're going to be using that iNaturalist app to document and share your observations. And then you're going to go in and delve deep into those observations and write them up and conduct a small presentation utilizing a rubric that I have provided. And again, you can submit the completed recording to, say, Brightspace. You can send it to me as a YouTube link or share through the OneDrive. And this has connections to other courses. For example, in Biology 101, we did a very similar exercise, but this time we increase the assessment and comprehensive nature of utilizing this iNaturalist platform. And that's really what our final exam would be. And so I'd like to would like for you to pay close attention to a few aspects in the final. First would be your submission. It's fully detailed in the uh, file that you can access on Brightspace, along with the tutorials, but also the rubric provided. And also, you to support your research, you do need to collect evidence from within the platform, but also peer-reviewed credible literature to generate evidence to support your claims as part of your defense, um, which would be the final product. And ultimately, this assignment is encouraging you to continue to connect with scientific inquiry in a real world application and emphasize the importance of just being a public, engaged individual for scientific literacy and awareness. And continue to connect the phenomena as a citizen scientist and keep learning about the natural world around you. As I want to be able to foster and continue your growth outside of this class. As always, if you have any questions about the material this week, please reach out and get a hold of me through video chat. You can send me an email or just swing by my office in room 208. And remember, I'm here to support you on your learning journey from week to week, even outside of the class, if you're interested in continuing to learn more about the different sciences that we offer here at the college. And once again, I'm proud of you for continuing on through this course and keep learning. That's all you can do is just keep learning about the world around you. That's the best way to think about science. Thank you.